Hey. Welcome back. This is week 2, question 4, longest palindrome. This one is an easy and it's going to be a string problem. This is number 409, longest palindrome. Given a string S, which consists of lowercase or uppercase letters, return the length of the longest palindrome that can be built with those letters. Okay, so it can be built. Given some string. Letters are case sensitive. For example, capital A, lowercase a is not considered a palindrome here. Okay, well that part is straightforward because it is a string and all these characters are different letters. So the input S equals, and these are all lowercase, A, B, C, 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 D, D. One longest palindrome that can be built is D, C, C, A, C, C, D. Okay, so I mean, if you look at something like that, this is a sorted list, and what you know about palindromes is that when you have a pair, they can be put on either side of something, right? So let's say you had a pair here. These are two C's. These are also two C's. And these are two D's. This is a palindrome, right? And this is almost what they actually have. So what they have is DCCACCD. So you can also have an optional middle character, right? So when it's odd, it has a middle. When it's even, there's no middle, right? So this is a palindrome, and then when you duplicate this and you take out the A, this is still a palindrome, right? So what do we know about this string that's going to give us the information? Well, we can go through this string and we can count the pairs. Right, here's a C, here's a C, here's the D pairs. So we can count the pairs. And the pairs are useful. In fact, if we just had a count, we'd actually be in a good place, right? So if instead of giving you a string like this, right, you were just given a count, right? So there's 1A, 1B, 4 C's, and 2 D's. Well, you know that, here, is this part of a pair? Let's count how many pairs there are. This is not part of a pair. And that means if you mod 2, there's going to be 1 left over. Here's the same. You mod 2, there's going to be 1 left over. Here you mod 2, and there's going to be 0. Here you mod 2, and it's going to be 0. So you know that these are made up of pairs, right? All pairs. And this, you don't know how many pairs, but it's 1 left over, right? So, that's, if I gave you this data structure, it'd actually be more useful than the string. Because what you can do is you can just iterate through, and for every count that's larger than 2, all those pairs are part of the palindrome, the ending palindrome, right? So let's say step 1 is create a counter, right? And then after you have a counter, you can iterate over all keys. And if it's if the value is equal to 2 or is larger, then we want to count the pairs, right? Or maybe we can aggregate the pairs in some way, right? Sum them. And then at the same time, if the mod 2 equals 1, then we know that we have at least one value to use, one letter to use in that optional middle section, right? This one right here. So what we're doing is we're counting all the pairs. So these are all the pairs that we're counting. Go ahead and put these in green. And then at the same time of counting those pairs, we'll just keep a flag or something that says that we also have an optional middle, and that adds to the ending count. So this is the pseudocode. We build the counter, step 1. We iterate over all the keys, and we take I guess I'll do this one first. We'll mod it, mod 2, and if mod 2 is equal to 1, then we set some counter variable, not counter, but some flag, right? So letter for mid equals true, right? And then if it's larger than 2, we count the pairs. And counting the pairs just means adding it to some result, right? So result plus the value. Well, it would be the result. We wouldn't want to add the value unless it was even. So if it's even, we want to add the value. But if it's odd, we want to add the value minus 1. Right, so here, imagine if D was actually, or let's say there's a different letter, and I'll make this yellow. Imagine there's a Z here, and Z is 5. Well, there's one for, the letter for mid equals true, but I want to count how many of these there are. How many pairs are there? So there are, well, if it's odd, it's just that value minus 1. And if it's even, if Z was actually 6, well, then it's just that value that I want to add. Anyway, this is basically the code. I think we have a pretty good sense of it. Now, let me go ahead and move this over. I think that's a good spot. So longest palindrome, let's create a counter. And then the step would be iterate over all keys. Counter object would be like this. And then for letter in S, let's say the current count is s.get the letter. Otherwise, the default would be 0. And then the new count would be the current count plus 1. And we can go ahead and set that, right? So as that letter equals new count. Now we want to iterate over all the keys. So I guess in a way it's not the keys that matter, it's actually the values, because we don't really care about the letter at this point. So for value or letter count in counter dot values, we're going to do something, right? So what are we going to do? So there was a flag here that we wanted to set, and there's a letter for mid. Make that false, right? And or I can actually just make that 0. So if this letter count is odd, right? This code that's actually right here, if it's odd, I want to set that letter for mid. I'll go ahead and set it to 1. So if this is a 1, the letter for mid equals 1. And otherwise, if this number is even actually, and this count could be, and even would actually mean 0, 2, 4, 6, 8, 10, 12. If it's any of these numbers, well, then I know that I can go ahead and add this as a possible count, right? So I don't have a count here. Let's call this a max. Just gonna say result, right? So result starts at 0, and what's gonna happen here is if this is even, I want to go ahead and add that to result. So result plus equals this value, right? This letter count. But what if it's not even? So what if it's something like a 7, right? If it's a 7, well, I still want to add it. So here I'm at is odd. Here I'm at is even. So if it's odd, I want to still add something to result. But I want to add letter count minus 1, right? So let's think about some values. If it's odd, if it's the number 1, I want to add letter count minus 1. I do want to add 0, right? Because I don't want to add any more. If it's 3, well, how many pairs are there? There's 1 pair, which means I want to add 2 to the result, right? If it's 5, I want to add 4 to the result. So here there's the 2 cases. And at the end of this, if there is a letter for mid, I can also add this letter for mid and then return result. And that's just the code, that I drew in this diagram here. And it's the code based on all of this. Oh, we don't have a get here. Oops, we're not doing the s.get. The s is the string. We actually want to increment the counter. And we have to do it in both places. All right, let's run this and see if it works. I don't know if I've checked all the edge cases. Great. So runtime 55. These numbers don't matter that much. Let's think about the actual runtime here. So we have a O of n operation here, right? Length of the string, we're creating a counter, and then the space as well. Now we have, every letter has its own key. I guess that's not really O of n because there's only so many letters in the alphabet. But what about this? So we're iterating over the values, and that's also O of n, right? It's just for every letter has a single value. And then we're just keeping a count, and we're incrementing a single number. So these are constant time operations here. We are checking if it's odd. We're checking if it's even. There's not too much to optimize here. Yeah. Anyway, thanks for coming. this was a fun one. Like and subscribe, and I'll see you on the next one.